Darmok and Jalad at Tanagra. Johnny, his table's dropped.
Matthew.
Michael.
Do you want to do a podcast?
Yes, I would.
We can also just do a podcast.
Okay.
Okay. Welcome, everyone, to Hacking the Grepson, where occasionally I do the intro melismatically. But I probably won't do that again because that took all of my melismatic energy, and it's all gone now. So now it's just every one syllable per syllable. Sorry, that's all I can muster.
I used to be Mel, and then I had a melismatic moment, and I haven't been able to revert.
I mean, you're not still Mel, but you used to be Mel too.
Yeah, right. Mel is Matt, and then I never changed.
Today, we're actually here to talk about something that I think both Matt and I have, we've been aware of this for a long time as software developers, but we've never done an episode talking about it, and that is the famous laws of software development.
Yes, this is our legal episode.
Yes. Now, we are not, I am not a lawyer, so don't take this as actual legal advice, but if you get caught in a court of law and you need to defend yourself against, Kirchhoff's principle, we're here to help you.
Dun dun.
Excellent. So this famous laws of software development, these are not actual laws. There was no governing body that did the Schoolhouse Rock how a bill becomes a law. These aren't written down anywhere.
Right. It's like someone said a thing and they're like, yeah, that seems to hold true, and then
enough people agreed with them over time, and now it's kind of been a law, sort of. I don't know. I don't know what else you'd call them. They're aphorisms, sayings, mottos.
Yeah. Rules of thumb is kind of how I think about it.
Yeah, rots. These are famous rots of software
These are some rots. Yeah, Murphy's rot.
Yeah, Murphy's rot, Conway's rot.
Yeah. I like it. Now, we were talking about these sort of in isolation, just on a separate topic. Mm-hmm. I don't even remember exactly why. Oh, I do remember why. I'm not even sure that one's in here. I have to make sure we add that if it's not.
Oh, okay.
And Mike was like, yeah, we should do an episode about laws. It's like, oh, that sounds fun. And so I just searched for it real quick, and we grabbed an article called Famous Laws of Software Development. It's by a guy named Tim Summer on timsummer.b, as in .be, not just the letter. That would be weird.
Yeah, where is that domain even from? I don't think I've ever seen that
Belarus
before.
is my guess.
Belarus.
It's 8 years old, this article.
Belgium.
That's a bad word.
It's a bad word? What?
There's a long story behind that, but the short version is Hitchhiker's Guide to the Galaxy.
Oh, yes.
One of the sequels, the original version just had the F word in it. It was a little short thing, and they replaced it with Belgium, and then there's this giant footnote about why Belgium is such a bad word and how Earth is backwards because of it. It's a really funny joke that no one gets, outside of a small handful of people. Mm-hmm. But back in my alt.fan.Douglas Adams days, that was used a lot.
God, Usenet. Wow.
Shout out to my Usenet fam.
Yeah. Use the net work. So, famous laws of software development. Right. Let's focus here. As we said, these are a bunch of sayings that someone said that got popular, so that it got named after them. Why they're called laws, I don't know, but that's what they're called. And I thought it would be interesting to go through some of these famous laws and talk about them and whether, we believe they're true, whether they've actually applied to you in your software development career, or whether we should just throw them out because they're dumb. I don't know. Let's get into it. I'll just start with the first one, which I would not necessarily say is a software development law. It's more of a technology law or a processor law, but it's, sorry, not processor law. I'm thinking of the other one. This is more of a life law, and that's Murphy's Law, which is...
Yeah, this is the oldest of the ones that I've heard of or that I knew about on this list. I heard about this as a little kid.
Yeah, and Murphy's Law succinctly is if something can go wrong, it will go wrong.
Yep.
Which, thinking about this in the context of like now being a 40-something software developer and not a kid, like it feels really cynical. This is like one of the most cynical kind of pessimistic laws or ways of thinking that I can think of, which is basically like if there is a chance that it will break or that it will go wrong or that it will fail, it will. Like it's kind of a self-fulfilling prophecy.
Counter argument to being pessimistic. I think it's a good way of approaching designing software to be fault tolerant and reliable and robust. Things will go wrong, and keeping that in mind to me isn't so much like everything's awful, and it's more like it's going to go wrong. I have to deal with it. I should design around that anyway.
Right. It's defensive.
Actually reminds me of the Stockdale paradox, which I only learned about recently, which is, in fact, Admiral Stockdale, who I believe was the running mate for Ross Perot, which was a big surprise to me after I learned about it, that's who it came through. But the Stockdale paradox is you have to, I don't have the exact words, but I have like a paraphrase on my whiteboard, which is confront the brutal facts, yet never lose faith. Or as I wrote it, everything sucks, but you have to stay hopeful that you will prevail. So Murphy's Law feeds into that, and it's like, yeah, everything's awful. Accept it, do something about it. Right. That's my follow-on to Murphy's Law. Stockdale paradox.
As Tim Summer says, things like the idea of defensive programming, version control, test-driven development, these are all ways of combating something. It's a realistic law. It is. If you don't want to think about it as pessimistic, think about it as realist. It's like entropy is real. Entropy is always increasing. Anything you do or create moves towards more chaotic, not less chaotic. And so the only thing you can do is to prepare for it. And that's sort of stating it in a very succinct way that, yes, I mean, initially could seem pessimistic, but yeah, if I it's more realistic than pessimistic, I suppose.
And the way I always kind of think about it as well is, I guess the kind of corollary to it isn't so much that it will go wrong, like it says, because Murphy's Law implies that every single thing that could possibly go wrong will, which is obviously hyperbole and not exactly right. But the way I like to think about it is when something goes wrong, you're like, yeah, well, Murphy's Law, right? It could go wrong, so it did, right? You shouldn't be surprised about that fact. Or the way I kind of view it, which is if something can go wrong and you're like, yeah, but that'll never happen, then it will.
So then it's kind of a karmic effect.
Yeah.
Like if you do things with some kind of elitism or superiority that you're above entropy, then you're now going to become a target.
Yeah, no one's going to name their kid Little Johnny Drop Tables, Like that's not that's silly. Why would anyone do that?
And that's an XKCD reference if you didn't get it, because it's kind of old and in the ancient lore of internet text now. For us,
Darmok
it's forever.
And Jalad at Tanagra.
But yeah, like XKCD.
Johnny, his tables dropped.
Amazing. Also, I was not aware of the derivations of this law, which is a mathematical term for, like from calculus. First derivation, if it works, you probably didn't write it, which also feels kind of pessimistic. Second derivation, which just seems funny. Cursing is the only language all programmers speak fluently. Haha. Yeah. And then conclusion, a computer will do what you write, not what you want, which just feels like another saying, restatement of the garbage in, garbage out. Like if,
I've never seen those before.
Neither have I, but I thought they were interesting.
Yeah. What's interesting now is to bring this very, what's the word for when something is apt for the present? It's timely.
Timely.
This is what happens when you get old, kids, is you forget basic words.
What are words?
It's very timely. If it works, you didn't write it. Yeah, because AI did. Although I will say, yeah, that's not true. So we're getting there, but we're not there yet.
Yeah.
Anything else on Murphy's Law?
No, I mean it's one of those things where it feels kind of tongue in cheek and hyperbolic, like you said. If you go too far down this line, it can get kind of cynical. It can kind of make it seem like there's no way to win because the universe is against you. If there's any chance that something will go wrong, it will. And so, like, never hope for perfection or never hope for even going towards perfection. But I think if
aim
you
for
take
success, not perfection. That's on. I have that written down somewhere. Aim
Exactly.
for success, not perfection.
Yeah, I think you have to take something like this with that huge grain of salt, where it is it's trying to make you better prepared. It's not trying to harsh your buzz, even though it could be taken that way. So yeah. I mean,
I was going to say one more thing on it. I'm trying to remember what it was, but go ahead and finish your thought.
Oh well, I was just going to say, because I was always curious about where it actually came from, and it's been attributed to a American aerospace engineer, Edward A. Murphy Jr., and his team while they were doing rocket sled tests back in the late 1940s. Although it's debated, so it might have been one of those things where, like, old Murphy probably said something like that. Let's go with it, even if he didn't actually say that specific thing. But it's more like
it got condensed and made more succinct over time.
It got calcified into this statement where and I'm a huge proponent in general that never let the absolute truth get in the way of a good story. And if the content is good and applicable, then whether he ever actually said that, it's sort of like the "Beam Me Up, Scotty" was apparently never actually said by anything, and yet everybody
or "Luke, I am your father."
Right. Yeah. It's just you get the point, and it doesn't hurt anybody to, I don't know, retell this thing as long as the kernel of truth is useful. Also, I wanted to say one other thing, because apparently there's also Muffrey's Law, which is not to be confused with Murphy's Law, and it goes, this is all from Wikipedia, it says, if you write anything criticizing editing or proofreading, there will be a fault of some kind in what you have written.
So often that is true for me.
So basically, don't act like your poop doesn't stink when you criticize someone else's poop, I think is what that's
I'm
saying.
not that good of an actor, Mike. Apparently, what Murphy actually said is, if there are two or more ways to do something, and one of those results in a catastrophe, then someone will do it that way. Which, honestly, is even more accurate to life. Now, I think when I first heard Murphy's Law, it was actually, if anything can go wrong, it probably will. Was the way I first heard it. And that was, I was a kid. I think I probably heard it from someone I knew that was in the military. So, I think it was more of a kind of like foobar and snafu and all those things kind of came out through that and entered popular lexicon. I imagine that one's there, or came through that. I remembered what I was going to say about Murphy's Law. Is there is tying it back into my old attempts at tying improv to software. Murphy's Law reminds me a lot of the Upright Citizens Brigade's addition to their corollary to yes and, which is, if this is true, what else is true? And another rule I hear all the time, which is make it worse, which is my favorite. Like, I'm stuck in an improv scene. What do I do? Make it worse. Make the situation worse. And I'm very good at identifying how something can go horribly wrong. Mm-hmm. And I attribute it to Murphy's Law and me having thought about this since I was a kid. Just being like, yeah, that could go wrong. What could go wrong? All those things. Hey, I'm catastrophizing things. Also probably helping furnish my therapist's apartment or something.
I mean, there's I think I brought it up an episode or two ago, that sci-fi, that was The Last Question. And it was all, about a question
the
about
final question.
Can you defeat entropy, basically? And even with an infinite amount of time, there it still was not enough data to answer that question. And so I mean, it's not like Murphy is really inventing some new idea, of what, thermodynamics or something. It always existed. It was just he put it in a way.
Well, so did the laws of thermodynamics. Right? It's just, this person quantified it into a thing. And they're like, yes, that is true.
Yeah.
And there's no mathematical proof behind Murphy's Law, though. So.
Yeah, but enough people agreed, and so it stayed in the popular consciousness. So, yeah. So, yeah, cool. Murphy's Law is one of those huge ones that just applies to, the world and existence. So maybe let's move on to the next one that is hopefully a little more specific.
All right, Brooks Law. I had not heard of this one before. Adding manpower to a late software project makes it later. Now, I've heard similar things out of like the Mythical Man Month and things like that of like, I can't remember what those rules were, but this states it pretty well, right? The more, it's too many cooks in the kitchen, it's all related to that same kind of thing. Adding manpower is not the solution to software problems unless you do it early on in the project and prepare for it. But just like, hey, this is broken, throw Matt at it. Okay, well, yeah, that probably will work because that is something I've had to do multiple times in my career. But it's not generally a good answer to just like, hey, get a couple more people over there that don't know anything about it and throw it at the problem.
Yeah, it kind of treats people as just like a one-to-one resource. It's like that old joke of like, if one woman takes 9 months to have a baby, how many months will 5 women take to have a baby or something like that? I think
it's actually 9 women. It's the question.
Or 9 women. Sorry, yeah. It should take 1 month, right? Because somehow they can divide the labor up evenly.
Exactly.
That's not how reality works.
Labor.
Yeah, it feels a lot like treating your resources as a one-to-one analog, and that's not how work actually happens. So that one seems pretty true. I mean, I don't have a lot of actual personal experience with that because I've never really worked on big teams and huge projects that would have that happen to them. So I'm almost always like a solo developer or a small team, and so the manpower, the people power stays consistent the whole time, and so I don't even know if that's true, but. So you have a better idea,
true.
Probably. It's definitely true.
Absolutely, absolutely true.
And that's why it's a law.
There's a whole book written on it, the Mythical Man Month, that goes into great detail. I think that's actually where the 9 babies or 9 women in 1 month can produce a baby or something like that. Whatever right. I think that's where I first heard that example was out of that. It's actually something that I think people with the type of experience that you're just describing that you have, if you don't think about it, especially like if it's a company that grows out of like a startup that's came out of someone's garage or whatever, scaling software development isn't as easy as throwing more people at it, right? There's a lot more to it. The more people you have, the more coordination you need, and then you need process, and engineers hate that for some reason. I love process because I'm an engineer, and I'm like, this goes, and then this happens, and then that.
Although I think in our current day and age of AI, like maybe this is less true because if you're just trying to compute something and you have one computer working on it and you're like, this is not going to get done. We need more compute. You add more compute and it gets done faster. So this feels like a human law, not a compute law.
I'd agree with that.
Yeah. Okay.
Not to get into the whole metaphysical idea and existential of like what is AI one or multiple entities, like each chat. I'm sure we've talked about that before. If not, I have an entire conversation with Claude where we don't do that. But, if you think about AI as, it's not really adding a person to it. It's adding a compiler for code generator, really. But yeah, adding compute to something's different. That's making the person smarter. That's not adding, it's Flowers of Algernoning the software developer.
Yeah, that is a larger topic, but I feel like, this law, I looked it up. You brought up the Mythical Man Month. This term was apparently coined by the author in that book. So that's why.
Oh, there you go. Cool.
Yeah, that's why it came.
Oh, was that Brooks?
It was Fred Brooks. Yep.
See, I didn't know the author of the book. I just know the name.
It's literally his law that he created in his book that you mentioned. So there you go. So basically, I don't need to read the book because he has a law, and I can just read the law, and I'm good, right?
It explains why, I think. Like, if you wanted to understand how to scale software teams and why that doesn't work, it's a good primer on that subject. Primer?
Okay.
Primer? I don't know the right term of that.
Primer.
Anyway,
Yeah.
What's the next one?
Okay, so the next one is apparently from The Big Bang Theory.
No.
No. It's actually it's called Hofstadter's law, And I believe, it is named after Douglas Hofstadter, who, one of the characters in Big Bang Theory, Leonard Hofstadter, obviously got his name from that because they're all scientists. Yes. But the rule states, it always takes longer than you expect, even when you take into account Hofstadter's law. So this is our first instance of a recursive law, which I love.
Love recursive laws.
And I 120,000 billion %, which is not possible, but you get what I'm saying, agree with this law that it always takes longer than you expect. Humans are terrible at estimating things in general.
Scotty's corollary to this one from Star Trek, just you take the estimate and you multiply it by 8 or something like that.
Right.
Just make it you just give an absurd time it's going to take because it's going to take longer than you think it will. Yeah. But probably won't take that long. And that way, when you do solve it, hey, you look like a hero. I did it in 5 hours instead of 20. How
exactly.
cool am I?
It's funny because like we've already brought up Star Trek once, but like in TNG in the Next Generation and Data, I remember early on one of his eccentricities that all the other humans around him kind of like, okay, let's slow it on that, was that when someone would ask him like how long it's going to take to get to that planet that we're moving towards, he would say, it's going to take
4126 seconds.
Yeah, 2 days and 5 hours and 43 minutes and 22 seconds. And, Picard would be like, whoa, we don't need that level of specificity. An approximation is fine because humans generally live in a world of approximations. We're constantly estimating and thinking about roughly how long something's going to take because it's not really that important that we know exactly how long it's going to take. But at the same time, we're really terrible at predicting how long something is going to take. We live in this like very foggy, rough estimation of time, whereas computers, are very accurate. Like we want them to be accurate because we have to do math with it and dates and times, and we don't want an error in there because we want things to actually happen when we think they're going to happen. But as far as like
because you can only like round, I guess, accurately or effectively, not because you're never rounding accurately, but you can only effectively round if you know the context, right? If I ask you what time it is and you tell me it's 10:45 right now, well, it's not. It's 10:42. Right. And if I'm just like generally like, I wonder what time of day it is, you're like 10:45, that's good enough. Right. Yeah. But if I'm like, I have to be somewhere at 10:46 and you say it's 10:45, you just cost me 3 minutes.
Right.
That's something I have in common with Data, I think. Because when people ask me what time it is, I do tell them the precise time. I don't round.
You're not about the approximation of like it's no. I think I'm the same way. If someone asks me what time it is, like I will look for a clock and I will tell them the time. I won't just say, I don't know, feels about 11, or it's late morning. Like that, I think that was probably more true before we had clocks. Obvious because you didn't know exactly what time it was.
Or so digital clocks in particular, right?
Yeah.
Like analog clocks, you can answer. Like it's about 10:45.
Right.
But if you say about, then it's okay.
Yeah, if you say about it's roughly, I don't know. It's kind of, if you couch it with I'm not going to give you a precise number, but also I think people back then before we had digital clocks were not expecting you so much to say, it's nearly a quarter till. That's enough. I don't need to tell you it's 10:43, because nothing is happening that precisely that you need to know that.
I think the Messerman-Chadwick law is that any topic will that can tangent will.
That's fine with me. I mean, tangents are the spice of life,
I agree.
So yeah, I think this is a pretty slam dunk true rule. I really have no notes for this one. It's true.
I'm curious. Are you familiar with Douglas Hofstadter at all?
Not really. No. What should I know about
There's
Douglas
one
Hofstadter?
of his books at least that I think you would dig, which is called Gödel Escher Bach.
Oh no, I've definitely read
Okay.
some of that before my brain probably got tired and I stopped.
That's Hofstadter. So
okay. Yeah,
now I need to make sure that I'm right about this because I'm suddenly doubting myself. No, it is. Okay.
He's a thinker for sure. That book is that's a tome.
Yeah. I have a couple of his books. He has some really good thoughts, especially around computer science. Like he's a really good thinker on subjects. It's the kind of thing I would like if I was writing software-y books. I think I would probably be in the more like in that meta space. That's how I think about things.
Yeah, I mean, GEB is a very interesting book. You know, it kind of reminds me of. Do you remember the guy Y in the Ruby community?
Oh yeah.
It's.
I want that style of explanation for everything.
Yeah, like he's like famous for writing stuff about Ruby and explaining it, but in this GEB kind of like, let's make a bunch of metaphors and let's have fun, and it's light, but it's also useful and educational. It doesn't have to be a dry textbook way of explaining something because that's not as accessible. So,
yeah,
totally.
That's how I explain everything. Also, we just came up with just Messerman's law while we were doing that. Is no matter how confident you are in your own knowledge of something, as soon as you state it publicly, you will doubt if you're right.
You should write that down. I like that. So basically, wait, do you want to reframe that as something cautionary? Like, in order to remain steadfast in your beliefs, avoid stating them publicly?
Something like that. But isn't that just it's better to remain silent and be thought the fool than to open your mouth?
Open your mouth and remove all doubt. Yeah, but that's more about public thought of your thoughts. This is more about like self-confidence.
Yeah. There's no way to doubt something better than to state it affirmatively. Or what's the word I want for that? Authoritatively.
Authoritatively. Well, and that reminds me of that. I don't think it's on this list, but there's that law about the internet where if you want to find anything out, say it incorrectly and people will jump in to correct you.
I love that.
Yeah.
There's I think it was Douglas Adams that has something, it might not be him, but it's someone along those lines of like, if you're ever lost, always carry a deck of cards with you and start playing solitaire. Because as soon as you do, someone will be like, move that red 7 to the black 8.
Totally. All right, so
next law?
I did Hofstadter. You do the next one, which was actually the seed for this whole
impetus.
episode.
Yeah.
The impetus, yes.
Yeah. So I got worried that it wasn't on the list. I searched it, and it was the next thing. I was like, oh, okay, cool. Conway's law.
Conway's
and the reason
law.
I thought about this is because it pops up in my life all the time. Because reorgs are very common in the corporate world. Any piece of software reflects the organizational structure that produced it. Another way of looking at it, as it's put down here, is organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. That is actually less clear, but
yeah. So how would you explain this? Because it's kind of deep.
So I've seen it used in two different ways, right? One is just sort of the truism of however your company is structured, your software will kind of coalesce into those same groups, right? If you have a client team and a server team, as opposed to like vertical slices, you'll approach problems differently. Is kind of the shortest version of that. But where I've seen it used in an interesting way, because has generally shown up as true so often in life, it certainly reflects my experience, is companies that do that on purpose, right? They will reorganize, they'll do a reorg to force the software, like without saying, hey, let's re-architect.
Oh.
Or whatever. They'll like restructure the org, and it kind of naturally happens, especially if you put someone like me on on that team. Because I'm like, wait, this doesn't make sense. We own this whole stack. Why are we breaking this up? Put it over here. Some people don't like refactoring. I live for it. It's great stuff.
I live for
but yeah,
it.
Conway's law is really interesting. In particular, like if you get too deep into this, in the like, how can I structure my org so that my software, blah, blah, blah. Like, it's not 100% accurate, but it's true enough, right? It really, and it's the longer you're in that org structure, the more likely it is that it's going to be kind of constrained like that. Where was I going with that? Kids, memory stops working when you're 40.
Reorgs?
Is reorgs. Oh, yeah. Is sometimes you can't organize your organization in such a way that it makes sense to how you would organize your software,
Okay.
right? Sometimes, like especially if we're going to go like a microservices approach, unless you have just a massive team that has like lots of little teams that you can do, it's probably not going to happen. But if you have a smaller team, you're often going to end up with like a bunch of little one-offs or silos within that team if they're doing a lot, especially in the kind of teams I tend to work on, which tend to end up being kind of the grab bag team of like, hey, all this stuff needs to happen, but it doesn't fit organizationally well.
Yeah.
Those are almost always my teams.
Okay.
Especially lately in my life. And those ones don't meet Conway's law, but they are affected by it pretty heavily. So,
Yeah, I feel like once again I have not worked in a large enough team to really be affected by this, at least consciously. I mean, I guess at my current job I have been reorged once, but it had nothing to do with the technical aspect of the job. It was all like way higher up organizationally in a like who I report to, but not what I do on a daily basis. So I'm not really sure how to interpret this.
I find the client-server boundary to be the easiest way to think about this problem. Because if you have a product that is a whole bunch of stuff, right? Let's say you're making a social media platform. If you have your client team or teams kind of reporting to one manager or one part of the org, and you have your server teams, your backend people talking to another, you end up with sort of a messier communication piece in between, right? Your API is a little bit less, it's probably more rigorous, or rigid rather. It's probably more rigid, but it's less clean. Because what's going to happen is your client teams are going to be like, I want to build this client thing. Well, I don't want to go wait for that other group over there to do a thing. So I'm going to write a BFF, right? A backend for the front end. And now I have that. So now I have my own communication path, and now we're doing server to communication for this other stuff. And it just ends up with like you end up with sort of messy structures, or you can there. But if you organize around verticals, like let's say this is the team that owns threaded conversations, just making stuff up here.
Like in Slack.
Then that feature will be more internally consistent, and the end-to-end flow will probably be a lot nicer. But that feature is probably going to look very different than than another feature that's on a different vertical. I have worked at all sort of different levels of how software can be, how organizations can be structured. From I'm completely on my own right now to I am leading the entire, I'm like the top software person in this place, and all the way in, and all the things in between. And I think I generally prefer working on verticals, but horizontals are easier. So like, I'm just a client developer. I'm just a server developer. I'm a full stack, whatever, right? And I think there's reasons to organize in different ways around that. I would often say like data should be its own horizontal layer that the verticals touch, and maybe the actual UI at the other end of it. But all this stuff in between that, I would tend to want to do as like verticals. That's just like my opinion, man.
Right. So as a law, since I feel like I can't really speak to it, so it's kind of on you. Like you would say that this is quite true, and there's not really. Yeah. Are there like any exceptions to this rule that you can think of, or is it just a self-fulfilling prophecy, basically?
It's a little. I'm sure there's exceptions. I think your case in particular is one, right, where your team isn't large enough to be broken up.
Right.
Period. So all your software is in one place. It doesn't apply. It's not that it doesn't matter. It's not applicable.
Yeah. I mean,
but generally speaking, in a large organization, even a medium organization, with enough developers working on something, if it gets above a single team working on software this starts to apply.
Yeah. I mean, from my kind of layman's viewpoint on this, as someone who has not really experienced this law, it seems like it's just talking about the way people on a team communicate, and the way they communicate shapes the way the product they work on is designed. And I mean, that just seems kind of like an obvious thing to say, but it's also good to state it because you want, because if it becomes a problem, you can kind of be like, oh, well, Conway's law is occurring here, guys. Like, you know why we're having issue?
Let's reorg.
Yeah. Why we're having issue A, B, and C is because the way that this team or these people talk to these people is affecting the way we are writing this. And I think about if you try to take this law and put it in a different context, because that's the only way I can really understand it, is sort of like if you and a bunch of friends, in college are sharing like a house together, and you're trying to figure out like how to divvy up the tasks and stuff. Like if you're all very open and willing to try and do different things, and you communicate, and maybe you have like a whiteboard where you write everybody's name down and you write like what their tasks are for the week, like the kind of environment you're going to be sharing this house in, which is basically the product, is a happy home that you're living in.
You're basically one team in that scenario.
Right.
You're all working together off the same list of priorities. Right. Which is a big part of why Conway's law happens, right? Is this priority over here differs from this team's priority over there, but they're both trying to do the same thing. And so exactly to your analogy there with the house rules. Like if everyone's agreeing, everyone's planning together, no problem.
Right.
But if you've got like, you're in charge of dishes all the time, 100%, then you've got people who are now just going to leave their dishes in the living room, right? Because it's not part of their job. Right. And now this person's job has become pick up the dishes, rinse the dishes, put them in the dishwasher, empty the dishwasher, and they're going to get real picky. Maybe they reduce the number of dishes available in the house.
Right.
Or they start assigning like rules about like only dishes that appear on this side of the sink will get washed or whatever, right?
Yeah.
And that's different than if you're all working together.
Right. I think you brought up a good point, is that I really should have thought about this from the moment you and a bunch of friends decide to live together. Like I kind of skipped over that and got to the idealistic, we talked about it and made a plan and wrote on a whiteboard. Like a lot of people don't get that far. And thus that kind of is a reflection of the communication that didn't happen. And thus the ecosystem of the house is completely different because of the lack of communication that you had. And so, yeah, I was describing the idealistic way that it might go, but most of the time, honestly, it doesn't. And then you get people, posting on Reddit about like, am I the jerk because I yelled at my roommate who hasn't washed dishes in 5 weeks? Should he be washing dishes more often? And everybody's like, yes, duh. Talk about it. Communicate it.
Divorce him right now. Oh, wait, no, it's a different type.
So that was Conway's law, which, as I said before, was kind of the whole reason why we even got into these software laws. And both that and Murphy's Law, feel like they really work on more levels than just software development. They just kind of talk about expectations and communication, which are important in all walks of life, not just software development. And I think that's going to, and there are more laws to talk about, but I think that's good for this episode. So let's touch on the other ones in a future episode. But for now, thank you for listening to Hacking the Grepson. You can get more of our episodes at hackingthegrepson.com. We put them out every other week on Wednesday. And until we discuss more laws with you, we now return you to your regularly scheduled lives already in progress.